Today, we are going to talk about abstraction. Let's recap a little bit. Up till now, we have seen that we can create classes, and using those classes, we can create many different objects. A class from which we can create objects is called a concrete class. So if this class can create objects, that means that this class is a concrete class. There are some classes which we cannot use to create objects. Those classes are called abstract classes. So why can't abstract classes be used to create objects? That is because they have abstract methods. In a concrete class, you have concrete methods. What does a concrete method mean? It means that the method has been implemented. Its implementation code has been written. So, for example, if this class has an add method like this, and suppose that it takes an integer x and integer y, adds them up, and returns the result. This means that this method's implementation code has been written. This is the implementation code. This means that the method is complete. It means that the method is also concrete. However, abstract classes can have methods that do not have an implementation written. Those methods are called abstract methods. So let's write some definitions. Concrete methods have method code implemented, just like we saw in this example. This code was implemented and we are actually getting a return. But abstract methods have no implementation code. For abstract methods, we only have the method signature. An abstract class can have abstract methods, and it can also have concrete methods, but this is not mandatory. We can have abstract classes with only abstract methods, but as mentioned here, we can have abstract classes which also have concrete methods. A concrete class can never have an abstract method. Any class that has an abstract method must be an abstract class. A natural question now will be that if abstract classes cannot create objects, then what do we use them for? Usually, abstract classes are parents of other classes. So different classes would inherit from abstract classes, and that's how we utilize abstract classes. So keep in mind that you have to inherit from an abstract class in order to utilize the abstract class. Let's get this out of the way. Great. How do we define a class to be abstract? How do we define a method to be abstract? We use the abstract keyword. Remember that this is not an access modifier. So let's say we want to create an abstract method for this class example. And let's say that method is multiply. At first, we'll have the access modifier. It can be any access modifier. We then define our method to be abstract using our abstract keyword. We then have the return type and then the name of the method and its input parameters. And that's it. You see, this has the method signature and it says that it is a public method, but it also says that this is an abstract method. The implementation of this method is not here, which is why this method is abstract. But remember that classes with abstract methods must also be abstract classes, which means that we need to define our class as abstract as well. And so we use the abstract keyword before we define our class. And since this is an abstract class, it cannot create objects, as we saw here. So let's get rid of these. Now that this class cannot create objects, what's the use of this class? This class can be used by another class. Another class can extend this class and implement the method code. If a new class extends our example class and implements the multiply method code, then that class will be able to create objects. Let's say there is a class that is going to inherit from our abstract example class. And let's say the class name is example2. If we want this class to be a concrete class, then it must implement the multiply method. It must have the implementation code of the multiply method. Of course, it can also have its own methods. So let's say it has a subtract method of its own. And let's say this is how the subtract method looks. So here, the subtract method has the implementation code, which means that this subtract method is a concrete method. But since example2 inherits from example, since this class inherits from this class, and this class has an abstract method, and we want this to be a concrete class, then example 2 must implement multiply and provide its implementation code. So when a subclass is implementing one of the methods of its parent class, we say that it is overriding that method. In the same way, example 2 must override example 1's abstract method. So now the child class has implemented the abstract method of its parent class. The child class has its own concrete method as well, and the child class has the constructor as well. All the methods of this class are concrete, which means that this is a concrete class. And because this is a concrete class, we can create objects using this class. But we will not be able to create objects using this class because this is an abstract class. But what if example 2 did not implement the multiply method? Let's say it never overrode the multiply method, but it still inherits from example. It still extends example. What would happen in that case? Since example 2 did not implement the abstract method of its parent class, example 2 itself has to be abstract as well. And in that case, we cannot create objects using the example 2 class as well. And so a third class might need to inherit from example 2 and ultimately implement multiply. And maybe from that third class, we will be able to create objects. The concept is, if a class inherits from its parent and that parent is an abstract class, then the subclass, the child class, has to implement, it must implement the abstract methods of its parent class. It must override the abstract methods of its parent class. If it does not override the abstract methods of its parent class, then the child class itself must become abstract. And we saw the example of that right here. However, if a child class or a subclass does overwrite the abstract methods of its parent class, then the child class becomes a concrete class. And we can create objects from the concrete class, like so. And we can create objects from this class. One thing to note here is that even though abstract classes cannot create objects, which means that abstract classes cannot be instantiated, abstract classes still can have constructors. But what is the use of these constructors? These constructors are used when the child classes create their own constructors. And we use the abstract classes constructor when we create the child classes constructor by using the super keyword. So these are some rules that we need to keep in mind when we are creating abstract classes. We have discussed the differences between abstract classes and concrete classes. And we have also looked at the difference between concrete methods and abstract methods. And now that we know how an abstract class can be created and how abstract classes can be inherited by subclasses, it is time to look at some code. Once we have looked at a code example, we will then try to analyze abstraction from a design perspective.